What we're going to do today is we're going to show you about differentials, implicit differentiation, and related rates. Calculus is the broad area of mathematics dealing with such topics as instantaneous, rates of change, area, under curves, and sequences and series underlying all these topics. Differentials are another way of writing and thinking about derivatives. They are used in the study of integration, and also, implicit differentiation is nothing to do more about special case of the way in chain rule for derivatives. And also, the related rates. It's a problems involve finding a rate which the quantity change by relating that quantity to other quantities with rates of change. Then the rate of change is usually with respect of time. We have general derivatives formula. We have the derivative of constant, which is 0, and the derivative of x to the power of n is equals to n x to the power of n minus 1. And the third one is the derivative of x, which is 1. And the derivative of u plus minus v is equals to the derivative of u plus the derivative of v. We also have the derivative of constant in u. Then we have c, the derivative of u. The number 6, we have the derivative of u and over v equals the derivative of u times v minus u derivative of v overall with v squared. And this one is the derivative of u to the power of n is equals to nu to the power of n minus 1 times the derivative of u. And the last one is for the chain rule. We have the derivative of u times v is equals to the derivative of v times the derivative of u times v. Now we have the function of 5x cubed minus 3x squared plus 10x minus 5. Now we will look for the first derivative. Now 5 times 3 x 3 minus 1 minus 3 times the exponent, which is 2, x 2 minus 1 plus 10 times 1, and x here is 1 minus 1, which is 0. Then we have the constant of 5, which is 0. So we have here 15x squared minus 6x to the power of 1 plus 10. Since 10 here is a constant, so we don't have 10 anymore. So our first derivative is 15x squared minus 6x. Now how about for the second derivative? 15 times 2 is 30. 2 minus 1 is x. Minus 6 times 1. And x here, 1 minus 1 is 0. So we have 30x minus 6. 30 minus x. So the second derivative of this function is f of x equals 30x minus 6. How about the third derivative of this function? We have 30 times 1 x. 1 minus 1 is equals to 0. And 6 here is a constant, so it's 0. So we have 30. The final answer for the third derivatives is 30.
Go.
So we have the second example. So we have the function of 2x negative 3 plus 3x squared plus 4x plus 2. So now here we have 2 times negative 3 x negative 3 minus 1 plus 3 times 2 x 2 minus 1 plus 4 times 1 and x 1 minus 1. 2 here is a constant, so constant is 0. So we have 2 times negative 3, which is negative 6. X negative 3 minus 1 is negative 4 plus 3 times 2 is 6. X 2 minus 1 is 1 plus 4 times 1 is 4. X 1 minus 1 is 0. So we have 4. So this one is our first derivative. How about in second derivative? So we have negative 6 times negative 4 x negative 4 minus 1 plus 6 times 1 x 1 minus 1. So 4 here is a constant. So 4 will become 0. So we have negative 6 times negative 4, which is 24. X, negative 4 minus 1 is negative 3. Negative 5. Plus 6. Plus 6. So the second derivative of this function is 24x to the power of negative 5 plus 6. But since in final answer, we don't have negative in our exponent, so we need to transfer that one into fraction form. So we have 24x to the power of 5 plus 6. This will be your second derivative of the function.
Alright, so now let me show you another example on how to find a derivative of a function. Now we have here the function f of x, which is equal to 2x plus 3 all over x squared plus 1. So as you can see, this is in a factorial form or fractional form. So to find the derivative of the function of this function, we are going to use the quotient rule, in which the quotient rule states that the derivative of u over v is equal to u times the derivative of v minus v times the derivative of u all over v squared. Now obviously our u here is our numerator, which is 2x plus 3, and our v is our denominator, which is x squared plus 1. Now to find the derivative of u, so we will just apply the rules that we have learned a while ago. So the derivative of 2x plus 3 is automatically 2. Why? Because the derivative of x is just 1 and the derivative of 3 is just 0, because 3 is a constant. Now let's move on to the derivative of v. The derivative of v is just 2x and just 2x. Because this is an exponent, you just bring down and multiply to the base and find the derivative of x, which is 2 minus 1. So 2 minus 1 is just 1, so we will just erase. Okay, now we will just copy the format. So we have our u, which is 2x plus 3. You multiply it with the derivative of v, which is 2x, and subtract to x squared plus 1 times the derivative of u, which is 2, all over x squared plus 1 squared. Now what we're going to do next is to distribute this. So we have 2x times 2x is 4x squared, 3 plus 2x is 6x minus. So in this one, we're gonna distribute negative sign here. So this will make positive 1 as negative. So we have x squared times 2, we have 2x squared. Negative 1 times 2, we have negative 2. All over the quantity of x squared plus 1 raised to the power of 2. So now we are going to combine like terms. So we have here 4x squared and 2x squared. So x squared, same term. So 4 times 2, we have 2. And then copy x squared. Plus, there's only one x, so just copy 6x minus 2, which is a constant. All over the quantity of x squared plus 1 raised to the power of 2. Now we already get our the derivative of our function, which is 2x squared plus 6x minus 2 all over x squared plus 1 raised to the power of 2.
Okay, good morning everyone. We are group task to report about implicit differentiation of calculus. But before that, we will define what is implicit differentiation and what is the relevance of this solution in connection to calculus. So what is the definition? These are techniques used to easily differentiate otherwise difficult equation. We have to use the rules for derivatives by applying them in slightly different ways to differentiate the complex equation without much any hassle. In addition to, it is also a way to take the derivative of a term with respect to another variable without having isolate the variable. Now, how to solve implicit differentiation of calculus? Let us take this example. Y is equal to x squared. Remember that the left part of our equation is y and the right part is x squared. In order to solve this through implicit differentiation, we need to get the derivatives of our left part of our equation. So how to get the derivative of our left part? Since we have here one imaginary exponent, we have to multiply on the numerical coefficient, which is 1 times dy over dx. Okay, next, since this variable is only y, so it is equal to, since the right part has no y, because we need to take only the derivatives if it has only a y variable. So dy over dx is equal to 2x. Okay, so why is it that this becomes to 2x? Because the derivative of x squared is 2x. Since we have one numerical coefficient here, so we need to multiply the numerical coefficient of this variable times the exponent, so which is 2x. So remember, 1 here can be omitted. So dy over dx is equal to 2x. Okay, next, let us take this example number 2. Example number 2 is x squared plus y squared is equal to 4. In our first example, we have only one variable on the left part of the equation, and the right part is also one variable. But in example number 2, we have two variables, which is x squared and y squared, and the right part of the equation is constant. The same procedure, the same process we need to follow. Just get the derivative of each term. So the derivative of x squared is 2x, and the derivative of y squared is equal to 2y, and the derivative of 4, remember that any constant, the derivative is always 0. So we need to put here 0. Okay, then, since 2x and 2y is the remaining terms of our equation, so we need to transpose our equation. So since this is only the 2y, so 2y will be remain on the left part, and we have to get also the derivative. But before that, we need to arrange first, and 2x will become negative 2x. Why is it that the 2x here become negative 2x? The same process what we discussed. Just let us recall the linear equation. The linear equation is we need to get the additive inverse. That is what we call the addition property of equality. The additive inverse of positive 2 is always negative 2. And copy the variable, which is negative 2x. I repeat, this becomes negative 2x because we get the additive inverse. And we also use the addition property of equality. Since 2y, we need to get the solution of 2y in terms of implicit differentiation. So 2y times dy over dx is equal to negative 2x. Remember that in this part here, we are using the addition property of inequality. But here, since we do not need to transfer the left part to the right part, or the right part of the equation to the left part is we are not required to use the addition property of equality, but we need to use the multiplicative inverse property of our 2y, which is 1 over 2y. Or simply, we will divide 2y in this part and 2y this part in order to omit 2y. And the remaining dy over dx is equal to negative x over y. So since dy over dx is the last term now, so we can say that the implicit differentiation of x squared plus y squared is dy over dx is equal to negative x over y, because 2 and 2 here will be cancelled, and negative 2 divided by positive 2 is a negative 1. Okay, negative 1. Okay, so this is our final answer, and this is also the final answer of our example number 1. So I hope that you understand about the implicit differentiation of calculus, and thank you.
Another example. X squared plus y squared minus 2x plus 3y is equals to 8. Now, in implicit differentiation, when x and y intermix. Now, let's first derive all the variable. Now, the derivative or the derivative of x squared is equals to 2x plus the derivative of y squared is 2y. Now, if there is a variable of y, we must multiply by dy over dx minus the derivative of 2x is 2 plus the derivative of 3y, 3. Again, variable y multiply by dy dx over dx. Now, the constant is automatically 0. Now, combine the two like terms. 2y dy dx plus 3 dy dx is equals to, now the 2x will become negative 2x. The negative 2 will become positive 2. Now, let's factor out dy over dx times 2y plus 3 is equals to negative 2x plus 2. Now, to get the derivative, we will divide it by 2y plus 3 both sides. 2y plus 3. So, cancel out. So, our answer, or the final answer of the equation x squared plus y squared minus 2x plus 3y is equals to 8 is dy of dx is equals to negative 2x plus 2 over 2y plus 3. This is the final answer. By the use of implicit differentiation, we can easily derive the equation in the easiest way. Now, let's have another example. The y is equals to sine 3x. Y is equals to sine 3x. Okay, automatically there's an exponent imaginary 1. So we can derive it by 1 or 1 dy over dx, because the variable is y. The derivative or the derivative of sine is cos sine 3x. Now, we will multiply it by its angle times 3. Okay. So, the final answer is dy over dx is equals to 3 times cosine 3x. That's the final answer of this equation. Y is equals to sine 3x. I hope you will learn our example for today, or my example for today. Thank you.
Okay, good day everyone. So I am here to talk about the related rates. Now we have an example here. A 25-foot ladder is placed against the wall if the bottom of the ladder is pulling from the wall at 2 feet per second. At what rate is the top of the ladder sliding down the wall when the top of the ladder is 20 feet above the floor? So 20 feet above the floor. So the ladder is 25 feet. So since it's like a Pythagorean Theorem, so we used to x squared plus y squared equals to 25 squared. So since we know that the y is the top of the ladder is placed 20 feet above the floor. So x squared plus 20 squared equals to 25 squared. So transpose with 20 squared to the right. X squared equals to 25 squared minus 20 squared. So x squared equals to 25 squared is 625 minus 20 squared is 400. So x squared equals to 625 minus 400 is 225. So square both sides. So therefore the x is 15. So since 15 is about 15 feet. So the y is 20 feet and the x is 15 feet. Now we apply the derivative. So what is the derivative of x squared plus y squared equals to 25 squared? So the derivative of x squared is 2x, since we don't know the rate. So dx in terms of time dt plus 2y dy over dt equals to the derivative of constant is 0. So we know the substitute now. So we have to substitute the value of x equals to the value of x is 15. And the rates of pulling the ladder from the wall is 2 feet per second. So 2 plus 2. The value of y, here the height of the ladder from the ground, so 20. So dy over t. So we don't know the rates. Unlike the pulling the ladder from the wall is 2 feet per second, but the rate from the top of the ladder to the sliding down, we don't know because it's not constantly related. So they are different rates. So we don't know. So we still about to remain dy over dt. So we multiply the 3. 2 times 15 times 2 is 60 plus 40 dy over dt equal to 0. So since we find the value of dy over dt, so we have to transpose 60. So 40 dy over dt equal to negative 60. So we have to divide by 40 to remain the d over t. So 40 over 40. So dy over dt is negative 60 over 40 or 1.5. Negative 1.5. It means that the rate is decreasing. Since decreasing because it's pulling down. Unlike here it's increasing because like the Cartesian plane, so we go to the right side is positive, but going to down is negative. So negative 1.5 feet per second. And now we know that the rates of the the distance of the ladder from the wall and from the ground is different. And that's all. Thank you.
So it says shape A is setting south and shape B is setting north. So this is one important thing. Any quantities that vary with time, you will label that with a variable. So certainly, this part, I will call this one as variable x. The distance from here going to north, south, as variable x, and in the sheet B, the distance going to north, I will call that variable y. Good day, everyone. In this video, I'm gonna do related race problem, and the problem says at noon, ship A is 100 km west of ship B. Ship A is sailing south at 35 km an hour, and ship B is sailing north at 25 km an hour. How fast is the distance between the ships changing at 4 p.m.? So, alright, so what we're gonna do here, a good thing for related race problem, works problem is that I can take the good acronym effectively or steps in solving this kind of problem. So I'm going to use, for the sake of solving these problems, is what we call DREEDS. So what DREEDS letter stands for? So the DREEDS D has come up with a diagram. Then R, label your rates. So this is the rates. And E, find an equation for that certain problem. D, think and take a derivatives. So this one is derivatives. This is sometimes an implicit differentiation is taken, and after taking derivatives, you substitute specific information. So this is substitute specific information. Okay, so I'm going to use this on this problem, this acronym DREEDS. So the first thing I'm going to do is come up with a diagram as stated here in letter D. So it says on the following. So at noon, ship A is 100 km west of ship B. So I'm going to use to make a diagram. So this is ship A. That is 100 km west from ship B. So this is the B, and this is the A. And it says that ship A is sailing south at 35 km an hour, so it's going to south. And ship B is sailing north at 25 km an hour. This is going to north. And the distance between these two ships is 100 kilometers. So this is 100. So this also tells me rates of what the ship is changing. So this is where you use your rates. So it says ship A is sailing south at 35 kilometers. So this is the rate of ship A, which is our x, variable x. So we can call this one change of x, that is dx, with respect to time, that is dt, that is equal to, here we have 35 kilometers an hour. And the same thing with the y distance. The change of the distance with respect to times can be written as dy dt, that is equal to 25 kilometers an hour. And we want to know how fast the distance between these two shapes is changing. And sometimes later and sometimes later is the diagonal between, maybe I call this z, variable z. So the diagonal starting from here. So I call this one as variable z. And when it changes to respect to time, I can write this one into dz over. So we will have now three variables, x, y, and z. And we are going to find the equation with relate each variable. And notice you can make this into a right triangle. So let's try to make this one a diagram into a right triangle so we can solve this and find an equation suitable for this problem. So here it is. So this is the y, and this is the x. I will get this and drop it with y, and this two distance fuse each other. So this come up like this one. This is the y and this is the x. And the distance, since the distance is fixed, so there's no changes happen. So this is the 100 kilometer distance of these two ships. Then the x distance we are going to find, which is also the changes of the distance of z from here going to here as the z, and the changes is the dz over dt. And notice this is a right triangle, and we can use Pythagorean Theorem to solve. Since we can use the Pythagorean Theorem, now we can come up with equations like this one. That is, this side is 100 squared plus, this is the sides, the other legal triangle, which is y and x. So this is y plus x squared is equal to z. And this time we do my implicit differentiation. So we are trying to solve dz dt in this problem. So we're gonna isolate dz dt. So this one. So the derivative of 100 square, which is constant, certainly that is equal to 0. So I'm not going to write that because it is 0. So only this part, which is doing implicit differentiation. So an implicit differentiation is just like something doing a chain rule. So the derivative of this quantity is 2 times y plus x times 1. The derivative of y is 1. So 1 dy dt plus 1, the derivative of x is 1, the x dt, so in respect to time. And the derivative of z squared is 2z. Again, with respect to time, this is dz over. So because we are going to find the changes or the changing of distance, the dz dt, so we're going to isolate the dz dt, that is dividing both sides by 2z. And This will become cancelled out. Then 2 also can be cancelled out. Then the remaining one is the dz over dt, which is equal to y plus x times dy dt plus dx dt, and over z. So we are done with the diagram, labeling rates. We found out the equation also, and we took the derivative, this one, the derivative, and now we need to substitute the specific information into the problem. So we have dx dt, which is equivalent to 35 kilometers an hour. So we can substitute this one, the dx dt here. That is 35, and the dy dt is 25, and yet we do not have the y and x value as well as the z value. But since we have already the equation of z, which is the Pythagorean Theorem, so we can substitute this one. So we are done with the diagram here, labeling with the rates. Then we found out also the equation using this one, the Pythagorean Theorem. And we took also the derivative, and now we need to substitute the specific informations into this problem. So we're going to substitute the specific information to the derivative equation. So we derive it already from here. So we substitute the specific information. So first, the dy dt. So here we are. So the dy dt is equals to, if you read again the problem, that is 35 kilometers an hour. I mean that is 25 kilometers an hour. Plus the dx dt is 35 kilometers an hour. And the y and x variable as well as z is, yet we do not have that value. But if we read the problem again, we understand that the value of x is equivalent to 140 and 100, because x, it says at noon ship A is 100 kilometers west of ship B at noon. Then automatically at 4 p.m. that is 4 hours frame time of that. So we can multiply that and the speed of x, the ship A, which is 35 times 4, that is 140. So we can input here x is 140 plus the y is 25 kilometers an hour. Within 4 hours, it takes 100 kilometers. So that is the distance of x and y. So how to find the value of x, which is the distance of ship A, traveling of ship A, that is, because it started from noon up to 4 p.m. So it is 4 hours after. So that is, the value of x is with the speed of 35 kilometers an hour times 4 hours gap of time frame. So that is 140. So the value of x. And the value of y also, this is 100, as the distance of y, which is again from 12 o'clock, which is noon, that is 4 hours also. So 25 kilometers an hour times 4 is equal to 100 kilometers. So distance. So we have here 100 kilometers. And to find the value of z, we will just substitute this one, the y plus x here in the Pythagorean Theorem to find this diagonal, the distance of the diagonal. So we can have the substitution of the value of z. So here, after solving this part, substituting, then we can have the denominator of this equation. Okay, to find the value of z, which is the diagonal, this one, the diagonal distance between the shape A and shape B. So the Pythagorean theorem is being used. So this is z squared equals to 100 squared plus the value of y as 100, and the value of x is 140 squared. So this is 10,000 plus, that is 100 plus 140, that's 240 square, and 10,000 plus square of 240, that is 57,600, that is z squared, and square root both sides. Take a square root both sides. So we have the value of z that is equal to 260. So we have now the value of z 260, so we can substitute this one. So we can have the denominator of dz over dt. So this is 260. So we can find now the value of dz dt, which is the target of our problem to solve. So we can solve now the dz dt, which is the changing of the distance of this diagonal. So that is 100 plus 140, that is 240. 25 plus 35, that is 60. So 240 times 60 is 14,400 divided by 260. Then we have the final answer of change of z in respect to time, that is divided by 260, that is 55.38 kilometers per hour. So what does it mean? 55.38 kilometers an hour. This means that the changing of this, or the speed change, it changes from here between these two ships as 55.38 kilometers during 4 p.m.